everyone, and welcome to our session. Today, we will talk about how you can optimize your costs for Kafka workloads and scale your streaming applications more cost efficiently on AWS. I'm Vidhi Taneja, and I'm a principal product manager at AWS for Amazon Managed Streaming for Apache Kafka. I have with me our rockstar solutions architect, Todd.
Hey everybody, my name's Todd. I'm a solutions architect, and I'll be back shortly to talk a little bit more about tiered storage.
Awesome. All right, so today we'll kick it off by discussing some of the emerging trends we are seeing from our customers that require them to store more data for longer duration in their Kafka clusters. And then we'll talk about some of the solutions that can enable you to do this more cost efficiently with lower overhead from operations perspective. So let's get started. So many of our customers use AWS for running their Kafka workloads. Now they've been telling us, while that's great, running Kafka themselves at high scale, at high availability can be challenging. So back in 2018, we launched Amazon MSK, which is a fully managed service for Apache Kafka and Kafka Connect. You can run it in a provision mode if you may want to have complete control over the cluster capacity or configuration. Or you can run it in a serverless mode if you may want to rather have a hands-off experience wherein you don't have to worry about right-sizing the cluster or balancing the partitions. It is 100% compatible with open source Kafka. So all the tools, connectors, the third-party integrations work as is. If you have self-managed Kafka running, it's as easy for you to just lift and shift those workloads over from self-managed Kafka to MSK without making any changes. It is highly available, scalable. In fact, we have customers running MSK ingesting over 15 gigabytes per second of data consistently on a single MSK cluster. It is secure by design. It offers multiple authentication and authorization modes. And it's deeply integrated with a variety of AWS services, be it Redshift, OpenSearch, IoT Core, AWS Lambda, so on and so forth. Now we have tens and thousands of customers running MSK at scale across different industries for a variety of use cases, be it for their real-time streaming ingestion, real-time analytics, or be it as a reliable backbone for some of their event-driven architectures. Now traditionally, many customers would use Kafka and store data for a few hours to a few days. But then our customers are telling us that they have use cases that will require them to store data for even longer, be it for training or scoring their machine learning models so they can have better and accurate predictions in real time, or be it for audit purposes for compliance reasons. They may have to sometimes recompute results if their application logic changes, or in cases where their downstream applications are facing an unplanned downtime, they may have to recompute data. So for addressing such use cases, often customers would want to store data for a few weeks, few months, or even a few years. And at AWS, Amazon S3 is one of the most popular destinations for storing data long term. And with MSK, we provide multiple integrations that enables our customers to simplify their data delivery to S3. First one being, MSK is fully integrated natively with Kinesis Data Firehose. It is a no-code S3 data delivery solution, fully managed. It has built-in transformations and provides guaranteed delivery of your data to S3. So in case of any failures, they're automatically taken care for you. Next, we have MSK Connect. Now, MSK Connect is our fully managed Kafka Connect service. It is fully compatible with all the third-party connectors. So if you have a connector of your choice, you can just bring over and run it on MSK Connect. And then if you may want to process your data before storing it for long-term storage, if you may have aggregations, or you may want to summarize data, or you may want to even enrich it with additional data, you can leverage our managed service for Apache Flink. Now, customers have been telling us, while that's great, ideally, they would not want to manage a separate system to store data for longer term. They would want Kafka to be their system of record to store data for longer duration. And Kafka provides retention policies at topic level. So it is actually well suited to be that system of record. But then the costs can quickly add up. In Kafka, storage and compute are tightly coupled, which means if you want to increase your storage, if you want to scale storage, you also have to add more brokers to the cluster. And what happens is your clusters often can be underutilized from compute perspective. And that increases the cost for the cluster. In addition, larger clusters with more brokers, more data, often require, you may often require to rebalance the data, which means you may have to move the data around, and the rebalancing times can often rise up as well. In case brokers fail, just recovery of the cluster itself can take longer. So in summary, our customers are telling us that they want to retain data for longer in Kafka, but they don't want their bills to go up. So to solve for that and address this need, we launched tiered storage feature last year in MSK. Tiered storage provides a low-cost tier in addition to high-performance local tier, and this low-cost tier scales to virtually unlimited storage. You can set your retention policies at each topic level. So you can specify, retain my data for this topic in local tier for these many hours or these many days, and in the cold tier for these many hours or these many days. So with tiered storage, you can actually scale your compute and storage independently. Because now you're storing less data in your local tier, you can rebalance and move around data much faster, so your rebalancing is much faster. As well as if there is a broker failure, the cluster itself is able to recover faster from those failures. And the best part is it comes all built in. There is no additional infrastructure for you to manage. It's natively installed with the click of button, you enable tiered storage, and you can just start setting your policies for your topics. Also, you pay for what you use. So based on how much data you're storing, how long you're storing, and when you're retrieving it, you're just paying for what you're using. MSK's tiered storage is based on the popular KIP 405, which is the tiered storage KIP. Now, as in the process of bringing this feature to our customers, our development team has worked very closely in partnership with Uber, with Kafka open source community, to help accelerate bringing this feature over to Kafka itself. The MSK developer team has been responsible and has been instrumental in reviewing over 85% of the tiered storage code. They have authored and co-authored the code commits, built various integration frameworks, they fixed critical bugs, and also proposed additional improvements to tiered storage. One of them is coming as part of 3.6 launch, and then rest will come as part of 3.7 Kafka launch. So we are very excited and happy to see tiered storage making its way in preview in open source Kafka very soon. Now in MSK, we have released this feature for about a year, and we have customers running it in production. One customer was actually able to achieve 56% of cost savings by just turning this feature on. Another customer reduced their cost economics, unit costs by 27%, while they were able to increase their retention 3 times. But that's not it. In addition to providing the best cost economics, tiered storage has also enabled our customers to better utilize their clusters. They don't need to now over-provision their storage capacity. They can scale storage independent of compute. So this has brought in storage elasticity to MSK and to Kafka. It has enabled some of our customers to bring really high throughput, high data volume workloads onto MSK and run them on MSK at lower costs. Tiered storage has also helped our customers to simplify their architectures. You could use same application code to process both historical and real-time data because now you're storing data for longer in your Kafka cluster itself. So in summary, tiered storage has brought in significant benefits to our customers, be it from cost efficiencies to reducing the operational overhead to improving the rebalance performance. So now let's take a further deeper dive into tiered storage, and for that, I'll call Todd back on the stage. Come on, Todd.
Thanks, Vinny. So, I think what Vinny has done effectively is answer, what and why of tiered storage. I'd like to talk to you all a little bit now about how, like some of the requirements, how you implement it on MSK, and what's sort of happening behind the scenes, and hopefully answer some of the questions that you might have. So we'll start by taking a look at the requirements for enabling tiered storage on an MSK cluster. It's two parts. First, you need to enable it on your cluster. And then the second part is you need to either modify an existing topic to make that remote storage enabled, or if you create a new topic, you do so with a couple of these new configuration parameters that are found in Kafka configs or Kafka topics. We'll come back to this later on in the demo, but this is as simple as enabling it on MSK. I want to talk to you about how it's implemented on MSK. And in order to do that, I thought it would be best if we level set on what life looks like without tiered storage on a Kafka broker. I'll go fairly high level, but stay with me on the various levels of abstractions. If we start on the left-hand side with a topic, hopefully we all know that a topic consists of one or more partitions. And the next layer of abstraction underneath that is the segment files. Now there's a couple of different files, but the partitions that contain the data consist of on the file system what are called segment files. And there's one or more segment files that consist of an active segment file as well as closed segment files. Now this is a simplified example up here. The only segment file that receives any new data, appends to the log, is the active segment file. After, either by default 1 gigabyte worth of size or a week worth of data written to a segment file, these segment files are rolled over and they're closed to the file system. Now over time, segment files will start to accumulate, and then back to the retention settings of your topic will be removed from the broker, either by size or time. So if that's a tour of what it looks like today, let's start to look at what it looks like with tiered storage. So I'll go through a series of clicks here, or events in time, and hopefully you can see that with the font. I know my eyes are going out and I don't really see it. The orange ones are closed segment files. The green one is that active one. Let's start with life before tiered storage, and we have, as described previously, we have a couple of closed segment files, one active. Let's say we enable tiered storage using the configuration options that I showed before. What's the first thing that happens? Well, if we set up tiered storage to have 2 days of local and 5 days total, immediately what happens on an MSK broker is those closed segment files are copied to tiered storage. Now, any requests that have an offset that require going back into the segment files from consumers, a fetch request, for example, will still read from those segment files if it's not in page cache. Next, after 2 days, now the local retention settings are in effect. The MSK broker will remove that off of the broker for local storage. Now, conversely to what I just said, if a consumer comes in that wants to go back in time beyond within 5 days, they will go back, they will go to the segment files in tiered storage and bring it back through the broker. I should probably mention, I'll mention it at some point, a common question is there any requirements on the clients or the producers themselves? There isn't any. There are some requirements on these new configuration options in Kafka configs and Kafka topics. But in case I don't mention it later on, let's make sure I mention it now. There's no requirements on producers or consumers. I'm jumping around here a little bit. If you're still with me, let's say after 5 days, we've reached the retention settings of that topic, similar to how it happens on a local broker. The closed segment files on tiered storage will be removed. Okay, so if that's how it happens from writing to segment files, let's take a look at what happens from a client perspective, a consumer, of making a fetch request. This is a summary of KIP 405. We have an option up there if you'd like to take a picture and look at KIP 405 in more detail, but I'll attempt to summarize. So if a consumer makes a fetch request to a broker, it's going to initially go to a replica manager. That replica manager will receive the offset from the consumer, and it will attempt to read from easy for me to say, read from local log at the top. If that offset is out of bounds, it will throw an out of bounds exception. That replica manager will catch that exception, and that's now an indicator to go to remote log manager, where it will retrieve data from tiered storage. From there, it will retrieve all the data that's needed and eventually come back to the local for that active segment file. Now, a common question that we get is, what's the performance of something like this? Is there a hit on something like removing or retrieving from tiered storage? And the answer is, the first few bytes, you will notice a bit of a latency lag, but just the first few bytes. Because what is happening on that broker is it's pre-fetching the closed segment files from tiered storage and loading into page cache. So after those initial first few bytes, you'll notice the same types of speeds as if you're local. I want to pull this all together with a demo. And in this demo, before I jump in, I want to just call out a couple of the key components of it. One, I've got an MSK cluster running. Two, I've got a data generator running in the background that's loading up some topics full of data. I've got a different couple of perspectives of looking at the Kafka cluster as we go from before tiered storage to enabling tiered storage. A couple of different consumers, command line, also a visual tool. It's an open source UI tool called Kafka. We're going to take a look at what's happening to the consumers as we're enabling tiered storage. Is there any sort of downtime, that sort of thing? And then we'll take a look at some of the different configurations. So we'll pull together everything that I've described so far. I think that covers it, all the things. There's a lot of stuff going on in this demo. So we'll start with before tiered storage. We're going to start off with Kafka. Again, this is an admin UI for Kafka. It's working with MSK. I'm calling out that there's just 3 brokers here, and we have a bunch of topics. We'll take a look at one topic in particular. This is an order topic. There's nothing special about the configuration of this topic. It's all default configuration at this point. We can take a look at viewing the messages. We'll see an offset of 54. As you can see on the screen here, it's just a bunch of JSON data representing an order. If we take a look at enabling tiered storage on this topic, we'll see that there's nothing, even from command line, that's different about that configuration. We have a Kafka console consumer that's reading from this order topic. Now, in the next step, if we enable tiered storage on this topic, what should happen? We're going to use Kafka configs. We're going to call out that remote storage is enabled, local retention, and then the overall retention. So we've updated that topic. And now let's go back to our console consumer. We can see that everything is still running just fine. Now I believe we'll take a look at some of the changes now that have happened. So if we view the messages in this order topic, we can see the offset has increased from 54 to 303. We can now see the new configuration that we set before. and we can continue to view messages. Now, if we describe this order topic from command line, we can also see the configuration that we enabled before. So hopefully this simplifies some of the answers of how to enable, what happens when you enable it in an MSK cluster. The console consumer is still running. So to recap, Vidi, if you'd like to come up, we've got zero infrastructure management with tiered storage, consumption-based pricing, fully compatible with Kafka APIs, virtually unlimited storage, and very, very similar read latencies. If you'd like to learn more, we've included some links here at the very top, and I'd like to thank you for your time. Also, if there's any questions or suggestions or any comments that you'd have afterwards, we'd love to hear from you.